present, such as at night or foul weather, an instrument approach landing is used. As the name implies, this relies on the instruments of the Hornet to provide a correct azimuth and glide slope approach to the selected airfield. Although the U.S. Navy Hornet in DCS world has the Instrument Carrier Landing System, or ICLS, this is only used for carrier landings and not airfield landings. Even in the real world, U.S. Hornets do not have ILS. As such, we'll instead use a TACAN approach azimuth and a standard 3-degree glide slope from a known distance measuring equipment and altitude. With a glide slope of 3 degrees, we can use a rule of thumb to calculate the altitude to start our descent. That being 300 feet of altitude for every nautical mile to the runway threshold. So, a DME of 10 nautical miles would be 3,000 feet. In this lesson, we will use a typical final approach fix with a DME of 10 nautical miles from the runway to start our descent. I currently have the lesson paused. Your QNH air pressure in inches is already correctly set to 29.92. In other missions, be sure to correctly set your altimeter based on the mission briefing QNH value. Press spacebar to continue. Using what you learned before, go ahead and set your left DDI to the HSI page and the right DDI to the FCS page. You would most often have the HUD on the left DDI and the HSI on the MPCD, but we'll use this setup to more easily monitor the HSI on the left DDI. Enter the Batumi TACAN code of 16X and set a course line of 119 degrees. This can be found on the airfield approach plate. The course arrow on the HUD will be your primary azimuth steering reference. Once complete, press spacebar. Before we unpause, let's contact Batumi Tower and let them know we're inbound. Press / to open the radio menu, then F5 to select ATC, and then F1 for Batumi. If you are using realistic radio, press the COM1 or COM2 to open the radio menu. Later, when Batumi Tower clears you for approach, press F1 to request landing permission. This will instruct the tower to turn on the approach lights. Press spacebar to continue. We now have everything set up for our instrument approach based on TACAN navigation with a controlled 3-degree glide slope from the final approach fix at waypoint 6. Once unpaused, fly to and maintain an airspeed of 250 knots and fly through the gate ahead. Ahead of you are a series of gates to help you stay on azimuth and glide slope. Make sure to fly through each one. When ready, press spacebar to unpause. Here we go. Reduce throttle to idle until your speed falls to 250 knots and maintain that airspeed until we reach our fixed approach point at waypoint 6. Note the TACAN heading on the HUD and HSI should be pointing directly ahead. To help slow down, you can use the speed brake by pressing left shift B to extend and B to retract. Fly through the gate ahead at waypoint 1. Once your speed is below 250 knots, remember to retract the speed brake if it is still extended by pressing B. Ensure your airspeed is below 250 knots and lower your landing gear and set flaps to full when 5 to 7 miles from the FAF. Passing waypoint 3 and your DME to the TACAN should be 15 miles. Keep an airspeed below 250 knots. Passing waypoint 4. Fly through the next gates on a 3-degree glide slope. To best determine your glide slope, reference the velocity vector on the HUD in relation to the pitch ladder. Fly to maintain the velocity vector 2/5 above the -5-degree pitch ladder line. Passing waypoint 5. Your next waypoint will be the fixed approach point that will place you 10 miles with a 3-degree glide slope.
To me, Colt 1-1. Request navigation assistance. Colt 1-1. To me, ADS, you're heading 306. Colt 1-1. Cleared for visual, contact tower. To me, Colt 1-1. Request landing. Colt 1-1. To me, cleared to land, runway 13, wind 126 at 4 meters per second. Colt 1-1.